When we say several flavors, there are actually many, many possibilities, because if you've noticed, .1x does not say how you authenticate. It just says what happens about closing the connection until you get the OK from the authentication server. EAP also does not say how you authenticate. It just says these are the typical exchanges that will happen between the different parties, the supplicants and the authentication server. But then how do you prove your ID? Password, something you have, something you are? EAP doesn't say. And there is, in fact, a vast family of possibilities. In Wi-Fi, you could spend days and days working on all the possible mechanisms that are in place for very specific networks. However, there are some main types that you see here: PEEP, EAP-Fast, EAP-TLS. Those are the very common types. Their choreography is a little bit different, but what matters is that in the end, you get a success from the authentication server and you can ride right through the access point to get access to your network. So let's look at the first one, EAP-TLS, which is probably the most famous because it's said to be the most secure. This is heavily relying on PKI, public key infrastructure, and therefore it's relying on certificates. So what's going to happen here is that once you pass the authentication phase at 802.11, where we just get you associated to the access point, we have this EAP over LAN start packet that can be sent typically from the client, but it can be sent from the other side as well. And then what happens is that the access point is going to say, who are you? And then you're going to return a name, your username. And then the packet is going to be relayed to the Radius server. And this is where the authentication with TLS is going to start. That's transport layer security. And what happens is that the server is going to send you its certificate. Your laptop is going to check that certificate and validate that the certificate is valid. That is important because that means that from that point on, you know that the Radius server you're talking to is genuine. It's not somebody trying to spoof anybody. It's a valid certificate. You could use the public key from a trusted third party that you both rely on. Well, then that's a genuine Radius server you're talking to. So that's proving the identity of the Radius server. And what the client is going to do once this validity is asserted is to return its own certificate. And that's going to be, of course, sent to the access point. It's going to relay it via the controller to the Radius server. And the server is going to do the same thing, check that certificate, verify the signature to verify that you are who you say you are. Your certificate is valid, it's not revoked. And now if that phase works well, you have on the client side the server certificate. And remember, it's a key. So the client can use that server certificate as a key to encrypt traffic to the server. And the server also has the client certificate, which is a key again. So the server can use that key to encrypt traffic sent down to the client. So now you have what we call a tunnel. You have some security through which you can go beyond this simple authentication and exchange secret traffic, during which you are going to generate some numbers, which we call the session keys, through which you are going to be able to generate that PMK. That exchange is going to allow you to generate the PMK. Keep in mind that the PMK is never sent over the air. But because you have this tunnel, you are able to exchange some numbering secrets that you're going to use as a seed to generate that PMK. So that's EAP-TLS. It's very secure. Once this is done, the authentication server is going to send the PMK to the controller or the access point, and then from there, you're going to use that PMK to generate the real key that you're going to use to transmit traffic encrypted to the access point. EAP-TLS is very secure because it's based on certificates. It's very hard to break if you have a third party you trust, and if the revocation list is recent, there is no real way to easily break EAP-TLS. The only thing about EAP-TLS is that it's cumbersome to maintain. Why? Because you need a certificate on the authentication server, that's okay, but you also need a certificate for each and every single client. So if you have 5,000 clients or 10,000, you need a certificate for each and every single of them. Every time you have an employee that leaves the company, you have to revoke their certificate. Every time somebody comes into the company, you have to install a certificate on their laptop, install a certification authority, etc. So it's cumbersome to manipulate and handle. If you are in a secure environment like banking, it's very common to use it anyway. If you are in an enterprise environment, well, sometimes people weigh the gain on security against the complexity of management. This is where another mechanism comes into play, which is called EAP-PEEP. PEEP stands for Protected EAP. And what we try to do with PEEP is to be almost as secure as EAP-TLS, but without having to have a certificate on each and every single client. So EAP-PEEP is in fact a pretend game. Because what we do here is the beginning is the same. We do EAP start. And then of course we send the identity request and you respond with a request and you respond with an identity. The thing about EAP-PEEP is that your identity can be anything. It could be your real name or it could be any fake name. Because in fact, we're not really verifying who you are here. We're just pretending we are. So we transfer your identity to the Radius server that checks your name, and maybe you're not even known in the database, it doesn't matter. We just pretend everything is fine and that we're doing EAP-TLS. So the server has a certificate and it's going to send you its certificate. At this point and so far, it's pure TLS. But what is interesting here is that the client is going to pretend to respond with a certificate, but the client does not have a certificate. So what is going to happen in fact is that the client is going to generate a number that is called number once, which is going to be a temporary keying material. And remember, because the client has the server certificate, it has a way to encrypt traffic that only the server can read, right? So the client is going to take that number, encrypt it with the server certificate, and return it back to the server. This is called a pre-master secret. But if you look from the outside, you look at the topology, the choreography, and you say, well, this is TLS, right? Identity request, we have the name of the guy, but then there is a server certificate, and when we get back on the other side is a certificate. So this is TLS, unbreakable, forget it. But in fact, it's not EAP-TLS. We don't have a certificate on the client. What we sent was a temporary number. But because we have this number on the server side, and we have the certificate on the client side, just like EAP-TLS, we have a mean now to exchange secret information without anybody being able to read it. So what we're going to do is another EAP inside the first EAP we did. That's why the name PEEP came from, protected EAP. We do EAP into EAP. And then we start again by saying, okay, seriously, who are you? And then you're going to return your real identity, your real username. And all this, as you see in the second red box, is encrypted, so nobody outside can see what you're doing. For them, you did EAP-TLS, you're moving forward to some exchange of traffic, but we don't know what that is. But in fact, you send your real identity. And of course, we'll ask you to send some credentials to prove who you are. The server sent its certificate, so you could use that certificate to check who the server was, but you never proved who you were on the laptop side. So this is where you do it. Typically, this is passwords. It can be also a token key, some different keying material, but password is very common. And of course, once this is done, we still do the same session key thing where we derive the PM key, etc. So that phase is the same. What is very different from EAP-TLS is that EAP into EAP, where you use password credentials inside a secret tunnel, pretending to be TLS. So PEEP has these two phases, right? The first phase where we pretend to do TLS, and then a second phase where we do this protected EAP and we do the real client validation. But then there is another mechanism which is called EAP fast. And to understand EAP fast, you have to think like a pirate or a secret agent. Imagine that you want to come into my network. I'm going to go and see you one day and say, you see that case, I'm going to give it to you. One day you'll come back to me and you'll have to bring it back. You cannot open it because only I have the key to that case. And by the way, the day you come back, I'll ask you for a password. And the password is going to be, and I give you a password, secret. Okay, by the way, my name is, and I give you my ID. Give you the case, and I go away, and you go away. The good thing is, I, the server, I'm going to forget about that box, your password, I forget everything, forget about you. And then after a few months, you want to join my network. You come back and you say, hey, I want to access your Wi-Fi network. And I wake up and say, all right, I'm server XYZ. I must have given you a box. Do you have it? And you say, oh yeah, you look into your boxes, and maybe if you access many EAP fast networks, you have many of those boxes, but one of them will have my name on it, my ID name on it. So you find that box, say yeah, and you pass it along to people that pass it to me. And I say you can pass it along to people passing it along to me because, as you remember, it's locked and only I have the key. So even if you pass it through people, they will not be able to open it and see what is inside. Then I get that box and I'm the only one, right, being able to open it. So what I do I open it, and guess what is inside? Your password, the one I told you, secret. And this is why I could forget about your password, because I knew that the day you wanted to access my network, you would give me that box that only I could open, and your password would be inside. So that's clever, because now at this point, I have a password for you. You wrote it down when I told it to you, so you have it too. So we can use each of us this password to exchange encrypted traffic, and we're going to use that traffic to identify who you are. That's the logic behind EAP Fast. If you remember this pirate or this top secret agent logic, you will be able to answer any question about EAP Fast. So let's go back to the slide and see how that works in the protocol. Officially, EAP Fast is divided into 3 phases. The first phase is in fact phase 0, and that's when I give you that box and your password. In that phase, in the official EAP Fast choreography, I give you what we call the PAC, Protected Access Credentials. That Protected Access Credentials contains a few things. Your password that you see in blue at the bottom. Then of course the server identifier, which is my ID. And then the PAC, which is in fact that locked box. So you get the 3 material. Of course, I have to give you that in a secure manner, just like for PKI, I gave you certificates and the public key from the trusted third party. This has to be done somewhere in advance, and the same thing happens here. Phase 0 has to be done in advance, and I have to convey to you those credentials in a secure manner. But that's provisioning, that's done before. Then when phase 1 happens, what you do, you try to get back to the network, and this is where I say, give me back that PAC. So you give me back that PAC, and as you see already, it contains what? Well, it contains your password, right? Your key. So what happens is that now, when we do the choreography, EAP starts just as usual. Then we say, who are you? Identity request, and you send your identity. Fine. But then that's where we have this exchange where I'm going to communicate to you my authority, my authentication ID, and then you're going to return the PAC. From that moment on, both of us have the password, and we can exchange encrypted traffic. Now, there's something important here, just like for PEEP. When I return to you the PAC, because I was given that PAC in a validated, secure fashion before, if you can open it, and if you can read as a server the password that is inside, that validates that you are at the right server. So the fact that you can read the PAC as a server validates the server identity, because only the right server has the key to open that PAC. So at that phase here, the client has not been identified yet. I could very well have stolen the PAC from someone, who knows. But that does validate the server, because if the server can read it, unless the network is entirely compromised, but otherwise, the server is the only one to be able to read that PAC, so I can trust I'm talking to the right server. So the next phase, and that's the second phase, so that's phase 2, we see here is phase 1. Phase 2 is where I want to authenticate also the client side. So here, I'm going to go back into that secure tunnel and ask again for the identity. And here, you're going to give me your real identity, and we're also going to exchange credentials, where you're going to use a token card or a password to authenticate who you are. So you see, the choreography is not very different from PEEP, but PEEP relies on a server certificate, whereas EAP Fast does not. The certificate is nowhere. It's just an EAP Fast server that generates boxes that are being distributed around. So that makes it very, very flexible. And because the server forgets about those boxes, because you're going to send them back anyway, it scales a lot. You can have millions of clients connected to the same server. So that's what makes EAP Fast very, very secure and very popular as well. However, because it was invented by Cisco and then published into some public documentations later on, it is not as widely adopted as PEEP. Anyway, once the authentication is completed, we still do the session key and PMK generation just as usual, and it's passed to the controller. So those 3 types, EAP TLS, very secure, a bit cumbersome. PEEP, maybe slightly less secure because there is a username and password somewhere and certificate only on one side. And then EAP Fast, no certificate at all and a large scalability, but probably a bit less used than the other 2, are 3 mechanisms that you need to know for the CCNA exam. But going a little bit beyond the exam, there are little subtleties in PEEP and EAP Fast, and the subtlety is about the versions. Because PEEP was developed by Microsoft and a few other companies together. And initially, the authentication mechanism for the client that was designed was relying on MS-CHAP v2. So you have a first generation of PEEP, which is called PEEP v0, and that relies on MS-CHAP v2 authentication from the client side. But MS-CHAP is very Microsoft, and some other vendors, including Cisco, said, well, maybe we can expand PEEP a little bit beyond pure MS-CHAP v2. So later on, another version of PEEP called PEEP v1 was released, and that one also allows generic token card, which are numbers that are generated as unique identifiers. So you have PEEP 0 and PEEP v1. On the EAP-Fast family as well, there are two generations. The first generation, which is called EAP-Fast v1, is actually invented by Cisco, right? And it relies on GTC, generic token cards. And the opposite thing to PEEP happened, where other vendors, including Microsoft, said, GTC is nice, but many people use Windows, and Windows use some other mechanisms, including MS-CHAP v2, and maybe something else like TLS, why not? So just like for PEEP, another generation of EAP-Fast came out, which is called sometimes EAP-Fast v1a, or v1b, or v2. And this one also allows, on top of GTC, MS-CHAP v2 and TLS to authenticate the client side. This is a bit beyond what you need to know for the CCNA, but it's good knowledge to know if you keep on going to CCNP wireless, for example.